Coming up in this episode.
Hey guys, welcome back to Retro Bits. Today, we're going to try something a little different from the usual format. Instead of a single long subject, there'll be multiple updates to projects that have appeared in past bits, as well as some shorts that don't merit a full episode on their own. I'll put chapter links in the description so you can skip ahead to the bits that are of interest to you. Sound good? Alright, let's get started.
First up, the Commodore 1902 monitor from way back in episode 5. After a full recap, the display still had issues holding vertical sync properly, as well as an overly sensitive mode selection switch. In that episode, I talked about replacing all of the components highlighted in yellow in an attempt to resolve the sync issues. Viewer Darren Hersey suggested in the comments that the switch might be partially responsible for the sync issues. Since it needed replacing anyway, I looked up the specs in the service manual and ordered a replacement. The new 4-pole, 3-position slide switch arrived from DigiKey in no time, so I made ready to replace it by cueing the music, as one does. With the mainboard disconnected and removed from the chassis, I got my first good look at the switch I was to be replacing, and another one of life's hard lessons. The original is an Alp switch with a different footprint from that of my new piece, and one that can't be found in any modern parts catalog so far as I can tell. Undeterred, I set about desoldering the old switch anyway, with the new plan of disassembling it and cleaning the contacts. Not my first choice, but having already come this far, it seemed better than nothing. Life wasn't done with the lessons today, oh no. Those switches aren't really designed to be taken apart. If you're careful, you can bend back the metal crimps without damaging any of the 20 delicate legs. You can see where this is going already, right? Ha! I got it apart without breaking anything. And would you look at that? The thing is absolutely filthy inside. It looks like there's tar or something on the switch. Arcing? Maybe it came from a smoking household, I don't know. But I'm glad I decided to clean it up, so clean it up I did. Hey, that's looking a lot better already. Maybe this will work. When you disassemble one of these, pay close attention to the orientation of these little sliding contacts, as you'll need to put them back exactly right when reassembling. I didn't, and so I had to look at the scoring pattern they left behind as they moved across the face of the switch bus and reassemble accordingly. Remember when I said the switches weren't meant to be taken apart? Well, as I was reassembling, I realized that there's no indication of which way the plastic selector cap gets oriented. You have a 50-50 shot of putting it on the right way, unless you mark everything during disassembly. So I took a gamble and reassembled everything to test. And as you already figured out, I had it backwards.
So everything had to come apart a second time, and the switch that wasn't meant to be disassembled had to be opened up again. Only this time I had done a really stellar job of crimping it, so it was much harder than before to get open. Guess who started to get frustrated? Yeah, this guy. And guess who broke off a leg? Yeah, the lessons were coming fast and furious that day.
But did I crack under pressure? Well, maybe just a little. But then I remembered a little something I had seen in the service manual. See it? Right there. I had a 7 in 20 chance that the leg I broke off wasn't even electrically connected to anything. And as it turns out, I got lucky with this one. Flip the selector cap 180 degrees, crimp the switch, soldered it back a second time, and drumroll please. So the verdict? Well, the clean switch works much better than before. The image no longer flickers in a slight breeze. The vertical sync is also greatly improved. The monitor can switch between different graphics modes without losing sync now, something it absolutely couldn't do before. Is it perfect? No, it still has a pretty tight range of adjustment, suggesting there are other worn components. But for a free display, it's getting better each time. Plus, just think of all the things we learned about slide switches today. Next, a quick update on the Mac Plus core for the MiSTer FPGA. In episode 31, I successfully installed Mac OS on a virtual hard disk, but was unable to get it to boot. It would either lock up or go into an infinite reboot loop. Well, just 6 days after that episode, an update to the core was released that included a commit with a disk I/O fix. Let's see how the update works using the same drive image from before. Hey, would you look at that? Problem solved. The Mac Plus core is fully functional now, and it gets even better because that wasn't the only commit in this release. Also added was support for additional CPU options, including a 68020 with speeds up to 16 MHz. Now, this is one zippy Mac Plus. So big thanks to Alexei for all he's done in creating and advancing the MiSTer platform. It just keeps getting better and better. In episode 29, I built this Commodore 64 Diagnostic test harness from a kit that was generously donated to the channel by Bill Atkinson. During the build, I incorrectly crimped some of the insulation displacement connectors and didn't have any extra for a do-over, so the end result only partially worked. Afterwards, I got on Amazon and ordered up a bunch of DB9 connectors and other common sizes I would need. When one piece is the same price as a dozen, you may as well have a bunch of extras on hand for when things go wrong. Armed with the new parts and a little more experience, let's do it the right way this time. Off with their heads. I can reuse the ribbon cable since I left plenty of extra slack the first time around when I measured the 128D. As before, it's important to make sure pin 1 lines up to pin 1. I just picked an arbitrary colored wire and used that as my guide. This time I also remembered to pull back the 10th wire before trying to crimp the DB9 connector. All done, and no mistakes this time, right? Well, we're about to find out. Heck yeah, a fully working diagnostic harness and C64. Awesome. The Roland MT32, an external MIDI synthesizer released in 1987, was considered the apex of computer music at the time. With an original price tag of $700 US, $1,600 in today's currency, it was unobtainium for most of us back in the day, but has achieved quite the resurgence in recent years. While obtaining a real MT32 is still a costly proposition these days, it is possible to emulate one instead, and that's where mt32-pi comes in. This project aims to turn your Raspberry Pi into a bare metal MIDI synth using existing software emulators packaged into a quick booting image. To complement the software, several hardware options are available in the form of Pi hats that let you interface your MT32-Pi with the MiSTer or other MIDI hardware. I don't own any of these hats yet, but there's no reason we can't play around with this stuff right now anyway. A number of existing MiSTer cores already support MIDI output, including the 486, Amiga, and Atari ST. While physically connecting to a MIDI device is possible with these hardware add-ons, several other methods do exist. The first is to run MUNT, an MT32 emulator, right on the MiSTer's ARM CPU. This does work, but the CPU isn't quite powerful enough to fully emulate the hardware DSP, and the music can lag, skip, or generally muck up. A better option is what I'll be demonstrating here, and that's to use a Raspberry Pi instead. The Pi has a much faster ARM CPU, so it handles the MT32 emulation better. It can also emulate other MIDI devices, such as the SC55 sound canvas, as well as load custom sound fonts. Now, I could load up MT32-Pi, but I've opted just to install the necessary software on my existing RetroPie setup. To tie it all together, I've configured MIDI Link, which will stream the MIDI commands from the MiSTer to the Pi over Wi-Fi, no cables needed at all. If there's enough interest, MIDI on the MiSTer could be an entire episode by itself, so let me know if that's something you want to see. In the meantime, let's give a listen to the MiSTer FPGA and Raspberry Pi living together in perfect harmony.
Roger Wilco as he rockets back toward his home planet Xenon, which he hasn't seen since Space Quest 2. Having successfully rescued those two ingrates from Andromeda, he decides a pit stop on Magmetheus is in order.
It's no secret that I like CRTs, and I've often lamented that here in North America, we never had a standard RGB connector like Europe had with SCART. This resulted in a free-for-all as each manufacturer outfitted their hardware with different styles of connectors. I wanted to be able to connect any device to any of my CRTs, so I've been playing around with different options. Today, I'm going to make a cable for the Commodore 1084S's analog RGB port, which uses a DIN 6 connector carrying red, green, blue, ground, horizontal, and vertical sync. DIN pigtails are readily available, such as this one, so let's break out the soldering iron and discuss the plan. For lack of a better option, I've decided to standardize all my equipment with RGB over SCART. In the original MiSTer FPGA video, I created a custom cable from the device's analog I/O board using a $1 thrift store VGA cable and a SCART connector. You don't need to roll your own though. RGB SCART cables are readily available on eBay and from overseas vendors for the MiSTer and most 16-bit era systems, making it a reasonable choice to standardize on. Further, devices such as multi-port switches and converters are plentiful, providing many options for connecting multiple, disparate devices to any type of display. Another issue that crops up is that some devices output composite sync, and others use separate horizontal and vertical signals. Some displays work with one or the other, and some, like the 1084S, can handle both. Different signal levels can also confuse or even damage mismatched displays. What we need is a grand unifier. And that's where the Sync Slayer 2 comes in. On one side, it ingests RGB over SCART. On the other, it outputs your RGB signal over a standard HD15 VGA connector. Jumpers allow you to convert C-Sync to HV-Sync and lower the signal levels with resistors where necessary. Around the side, a screw terminal gives you access to all of the signals, including audio and power. This is super handy because it allows me to capture 15 kHz video straight from the VGA port and drive a monitor at the same time. And for the monitor, I chose a standard DE9 connector that fits the Commodore 1902 and others, as they are readily available in the form of a cut-down serial cable I had lying around. That sorted, I built adapters for each other type of display, just like the DIN 6 cable from a minute ago. With this setup, I can use any system with any display while simultaneously capturing on a PC. It's a bit of a mess of wires, but it isn't the final form yet. I'm still experimenting and trying different ideas out. So how does it all work? Well, you be the judge.
So that's it for today's project updates and shorts. Let me know in the comments if you like this new format, you'd prefer shorter, more frequent updates, or the whole thing's an ill-conceived mess. I hope you enjoyed this episode. Thank you so much for watching, and we'll see you next time on Retro Bits.